Alright, g'day weebs! I thought I was done with this, but apparently this type of isekai, Pharmacy Isekai, is really popular. This one just came out yesterday, I believe, the first episode, Isekai Yakkyoku. So fairly straightforward, Isekai Pharmacy. We'll see how this one differs from the last one I looked at, or now it's like nearly 3, 4, 5, 6 months ago, something like that. I'll put a link up there in the top right for you. And that particular pharmacy tended to more lean on the isekai side of things, so there wasn't a lot of chemistry or things like that, which, you know, might be a little much to expect. But judging from the 0-0 point of this first episode, I think we might be getting into a little bit more technical detail in terms of how medicines are made and things like that. But we will see. I will generally skip through most of this stuff. There'll be a timestamp in the bottom right there for you so you can follow along. And I'll point out scenes as they're relevant to pharmacy, as I did so before. If you are worried about my credentials, I was an Australian registered pharmacist. I gave up that registration because now I work more in the research side of things, so I'm not working in community or hospitals anymore. I did work in community for roughly 3 years as a pharmacist, and then I was also working in community pharmacy while I was still a pharmacy student. So I still have decent knowledge about drugs, and especially when it comes to drug research, that kind of thing. I don't know why my light just turned off, but yeah, when it comes to drug research, things like that, I've got a little bit more ideas, especially as it gets later on into development, into human testing and human research, that kind of thing. So let's get started, shall we? Okay, alright. Yeah, so we're definitely in the more technical aspects of things. Hichiki were obtained from ATGC and something. Some 10% bovine serum and antibiotics, penicillin. Yikes, this is really deep into it. So I never really worked in the lab in terms of how drugs are researched and how they're found and things like that. But generally, from what I remember from my university education, is that drugs essentially do one of two things. They either activate something or they deactivate something. That's a very gross oversimplification, but it'll do for now. First, when you're looking to combat a disease, for example, so let's say like the flu or asthma or a cancer or whatever, you need to first study the disease, obviously, right? You need to find out how the disease works, how it works in your body, what's causing, the symptoms, and how you can stop those from occurring or stop the disease from propagating, something like that. You essentially need to find a point in the chain where you can break it, essentially, right? With the right molecule, the right way of stopping that cascading flow of events, essentially. What that means, in more practical terms, is like a piece of Lego, right? You find the right piece of Lego that goes together with the right piece in your body, and they kind of join together, and when they join together, they produce the desired effect. So, for example, for painkillers, very simple is that in your brain, especially for opioids and things like that, in your brain there are certain receptors in your brain that they can receive different types of molecules. Some molecules cause pain, some of those molecules, will not cause pain, that kind of thing. Essentially what opioids do is that they block those receptors in your brain, so then the other molecules or signals that your brain sends can't connect with those receptors, so then you don't feel pain anymore. Really simple. And that's kind of the really basic idea about drug development, is that you're finding something that fits into a receptor or is the correct Lego piece that fits into the spot in your body that prevents the disease from propagating or prevents the symptoms from continuing anymore, or somehow helps you fight the disease as well, is another way of thinking about it, or is another way that another strategy that scientists use, that researchers use. When they find a molecule that fits those receptors or things like that, they then go into in vitro testing. So this isn't hang on, I need to get this right. Yes, so in vitro testing. So essentially what's performed outside of the body in petri dishes, that kind of thing, using tissues or other samples, right? That will show that it is having the intended effect. Obviously, this is a lot harder in a lab, and these tests are performed to at least at baseline ensure that they have A, the intended effect, and B, that they're not going to be as toxic or poisonous or whatever, right? From there, they then move into animal trials, usually in mice, something like that, where they can test it in an actual living organism and see if it still has the intended effect, and kind of titrate the dose that way to make sure that they're not, going to accidentally kill anything or cause more harm than good, right? Because all medicines are poisons, just depends on the dose, right? This particular screenshot where he's in his Word document typing up basically his research, right? This says to me that he's currently in the in vitro process, so outside of any living organism, things like that, because the cells that are obtained from ATGC, which are just the DNA bases, so I don't really understand how they can be obtained from the DNA bases, but, I'm not in this specialization. We're supplemented with 10% fetal bovine serum and antibiotics to produce a certain effect at body temperature. And it says further that there were transfers of infectious material performed into 96 well plates. So 96 well there is describing, I believe, someone else could probably correct me on it, who's closer to this, but I believe in a petri dish or whatever they're using to grow their cells, they've created 96 little divots in that petri dish where they inoculate, the virus or whatever they're doing, or the piece of tissue. So in one petri dish, they have 96 spots, essentially, where they've put the infectious material. They were performed in 96 well plates using Lipofectamax 9000. That sounds to me like it's a made-up medication name. It assumedly is an actual molecule name, not the brand name, because the brand name is in brackets in Vitron. Hello, Future Jaded Weeb here. I just wanted to point out that I got a few things wrong. So transfection here refers to the introduction of DNA to animal cells, essentially. So transfection, right? The portmanteau of transferring and infection. So it's changing animal cells by introducing new DNA to those cells. And the brand name, the Lipofectamax, whatever, 9000 or whatever, is actually a trade name that's been changed from Lipofectamine 3000, which is an actual reagent used for transfection in the real world. So I didn't know that, and I was just making sure I was crossing my T's, dotting my I's while I was editing. And so any reference I make to infected material or anything like that, technically I'm still correct, but in this case what I mean by infected material should refer to animal cells or different cells that have been that have had DNA introduced to them to change their behavior or change their characteristics, I think. Lipofectamax 9000, that doesn't sound like anything any self-respecting scientist would name their molecule, but there we go. According to the manufacturer's protocol. Interesting. So protocol in clinical research kind of means the method, right? So the method of how they performed an experiment. So essentially what this says is that they're doing this transfer of infectious material using the manufacturer's molecule according to how the manufacturer did it. I don't know what protocol it's really referring to. This is just one screenshot from like the first 16 seconds of the episode. You know. S2 cells were obtained from National Genomics Resources Center. S2 cells, no idea. Cultured in Schneider's medium, supplemented with 10% heat inactivated FBS and antibiotics. 10 units per mil penicillin and 50 micrograms per mil streptomycin at 25 degrees Celsius. Alright, Schneider's medium, I don't know exactly what that is, but my guess is that it's sort of like what you use to grow stuff in petri dishes, things like that. So, you may have heard of agar, that kind of thing. It's essentially just food for whatever bacteria or things that you're growing in it. So then you have something that will fix the bacteria to the spot wherever you put it, and also make sure that the bacteria still grows and is living, that kind of thing. So you can perform experiments on it. Cultured in that medium, that agar, essentially, or agar in inverted commas, because it's not really agar, apparently. Supplemented with 10% heat inactivated FBS. Don't know what FBS is. Sounds like it's some sort of virus or bacteria. Heat inactivated tells me that it's probably a virus, but I'm not sure. I don't know why, if it is a virus, because they then supplement it with antibiotics. So virus doesn't really make sense. Antibiotics, 10 units per mil penicillin, 50 micrograms per mil streptomycin. Don't know why this is using units and micrograms in like two different units for the two antibiotics. I don't understand why you would just not use micrograms per mil or units per mil, like either or rather than both. But penicillin and streptomycin are both antibiotics that do exist. They do exist. Penicillin obviously is the more well-known of the two. I'm surprised in this, whatever this year is, 20XX or whatever, that they're still using penicillin. At 25 degrees, sure. This is just some method, pretty much. I don't think there's really much more I can add from there. But it looks pretty interesting. So from this particular shot, it looks like he is currently in between. He's found the molecule that he knows works with the receptor. He's found that Lego piece, and now he's in the in vitro testing part of it, right? He's trying to test it on cells outside of a living organism to see if it works and does what he needs to without necessarily killing everything else. So, yeah. I will also add, this guy clearly has a lot better background than the guy from the previous series who was just some random salaryman from Japan that got hit by a truck. So, you know, it's pretty good. If this is our protagonist, that is.
はい、すいません。製薬会社の方が共同研究のご相談にお見えです。
Okay. So yes, pharmaceutical company representative here to discuss joint research. So big pharma companies do conduct research all the time, pretty much. They have their own R&D, they have their own scientists that are constantly trying to develop drugs to for specific illnesses, that kind of thing. They do also sometimes reach out beyond that to other, we call them investigators, researchers, scientists, etc., to conduct research. I haven't really done much of that, of investigator-led research. I'm mostly still kind of on the big pharma side, essentially, is who I mostly work with. Now, when I say big pharma, that doesn't necessarily mean it's Pfizer or what's the word? Pfizer or GSK or RB, Reckitt Benckiser, or like the really big pharma companies. It could be like small startup biotechs, that kind of thing, that don't necessarily have have a molecule that they want to test out in human beings, and they may not necessarily have the clinical research personnel in-house to be able to do it. So I work for a company that specifically does clinical research. So we do clinical research for our clients, and we conduct those studies for them. And it's not necessarily always a big pharma company. Sometimes it's a small biotech. Sometimes like everywhere in between. Sometimes very unusually it's universities, but they don't tend to have, unfortunately, the funding to be able to pursue those kinds of studies, because it does take a lot of money to ensure that, you know, patients are protected and the data is clean, and, you know, that you're conducting the clinical trials correctly so that they collect the correct data in order to prove that the medication is safe and efficacious and things like that. So, yeah, this sometimes can happen.
ヤクタニです。本日はよろしくお願いします。ご案内お願いします。すぐ行くので。
お忙しそうですね、ヤクタニ先生。
Essentially, you can think of my job as kind of like this guy, but probably I wouldn't be said as a representative. I'm not really there necessarily to like advertise from the company. I'm just there to make sure that the science is all good. So yeah.
まったく。
ヤクタニ先生のご研究は間違いなく世界トップクラスですもんね。将来どれだけの患者さんが救われるか。
He saves his little sister. Oh my god, it's always about little sisters, isn't it?
Oh, こんな時間か。
Yeah, a lot of these investigators tend to be very worn out and very busy. But the investigators also tend to be doctors. So I don't know why a straight scientist is necessarily getting, unless he is also a doctor. Entirely possible. By doctor in this instance, I mean someone who is medically qualified. They don't necessarily have to be a specialist in order to participate in clinical research, depending on what illness you're investigating. But they generally are. Well, they kind of have to be medically qualified.
じいちゃん治る？お薬飲んで寝たら治るよね。
取りきれないところに腫瘍が。運が悪かったのね。
諦めるしか。薬も効かなかったらしくて。
諦める。運がなかった。冗談じゃない。ちゃんと効く薬があればよかったんだ。
Yeah. That can get very difficult, especially in community settings, and even worse in clinical research. The clinical research does help patients in that it offers another option where necessarily other options have run their course. The only problem is when clinical research doesn't always work, right? That's part of the scientific method, is that sometimes like you're pretty sure that it'll work and it'll have a good effect, but you know, there's still things that we don't know about. And those kinds of conversations with patients and patient families, when it comes to that kind of ending, is pretty hard. Thankfully, in my work nowadays, I don't usually see the patients, because if I saw the patients, for example, that could be conceived as a like tampering with the data or tampering with how the trial is run, because, you know, at the end of the day, the whole point of all of this is to ensure that the patients get the best care, and that should mean that the investigators, the doctors, are free from any influence apart from, you know, being offered the chance to offer patients a new pathway that they may not necessarily have. So I personally haven't had these conversations in a while. I've had a couple of them before in community, where, you know, a lot of the time in community it's not necessarily something that you expect to have. But yeah, these conversations are always a little bit difficult to have. I do also want to point out that the age of where research is conducted by one brilliant person in a lab by themselves is long gone. It is usually teams of people, like massive teams of people. The idea that one guy can think of a molecule by himself and then be able to develop it all the way to completion, it's almost a pipe dream. Even if the guy figures it out in a university, he likely won't have the funding, he won't have the facilities, he won't have the expertise to be able to, you know, mass produce it, to make it commercially viable, to even make it like medicinally viable. It usually takes a lot of people to ensure that a medicine is sufficiently efficacious to the point where it can be produced in great enough quantities where it does go out to patients to cure them. And, you know, there's a lot of conversation about, you know, the cost of medicines and, you know, how much should medicines cost and things like that. And it is a unfortunate reality where, you know, in order to be able to make things in a capitalist society, you need to ensure that it is commercially viable, where it does make sense that you get more money than you spend, right? You know, governments and other entities can help with the cost, and they certainly do, especially in a lot of the world. But you know, there are instances where just the technology isn't there to be able to make it viable to produce enough quantities to cure some diseases. Now that isn't very often. There usually is a way, because everyone in healthcare essentially wants the same thing generally, which is to help patients get better. So more often than not, there is a way forward in terms of money and things like that. But, you know, sometimes it is legitimately just a technology barrier where, you know, sometimes a molecule is found and they can't have the precise enough instruments or whatever to be able to produce it in enough quantities. Doesn't happen very often, but sometimes.
3時42分開始、終了は4時42分と。46分後、患者さんと向かい合って話したのはいつ以来だ。
So he is medically qualified, good.
ゆくゆくは町の薬剤師になるかな。
Well, okay, so it is implied that he's a pharmacist currently working in research and drug development, but he used to interact with patients. That's very interesting. I mean, of course, there are definitely pharmacists who work in drug development. That's part of our education. But in my case, I didn't go down that path. If you wanted to do more drug development, then generally after you do my degree of Bachelor of Pharmacy, you'd go on to do, you know, a master's or a PhD, or I definitely know some people in honors who are doing small parts for that, where they only had a year, so not a huge lot, but you know, drug development is definitely a career path that some pharmacists can choose, or that pharmacists can choose in general. But to have a mind for that kind of thing is very rare nowadays, I think, because it takes a lot of trial and error and a lot of deep study to be able to even understand these disease pathways before anyone else does, and then figure out what receptors or proteins or whatever you want to call it to target. Yeah. We haven't even gone past like 5 minutes of this bloody episode. Oh, he's dead. Is he dead? Isekai.
先生
Ooh. Yeah, Isekai, baby. Welcome to your fantasy world, buddy.
お目覚めになりました？いけません。ファレマ様は雷に打たれたのですから。思い出せます？何を言って。
Alright, clearly this is where I have no technical expertise, so we'll probably skip through a bit of this, see if he has anything more interesting to say. Alright, this OP, there was a bit that just stood out to me. It's coming up in a little bit. Yeah, Magic Eye. Now, they're doing... That is some hyped up kit for a fantasy spot. Where they have, you know... They're trying to have full biohazard gear, right? So they have the hood and everything to try and make sure they're sterile. Oh, can I go? Yeah, so... You know, they've got microscopes. Don't know how they made those. Some lamps. And they've all tried to have as much biosecurity as they can. That's pretty interesting. I don't think necessarily this would be useful in a fantasy setting, mostly because you don't have the technology in order to be able to ensure a sterile air environment, for example. Because in these kinds of cases where you are, for sterile compounding, for example, when we're making medications that are supposed to be IV and things like that, there are ways to ensure that you have absolutely sterile conditions in the manufacturing facility to ensure that, you know, the whatever you're preparing doesn't get contaminated with anything, which is especially important for like cancer treatments, that kind of thing. So I don't know really why they're dressed up like this. I guess it does help, because, and like any little bit helps, and this is probably a huge leap forward for this particular society. The only other thing I will touch on in this OP is that they show the chemical formula for levofloxacin, which is a quinolone antibiotic first discovered, I think, by Japanese scientists. Yeah, by Japanese scientists at Daiichi Sankyo, which is a very old pharmaceutical company in Japan. The second largest one after Takeda, probably, or Takeda, depending on which way you say it. This particular quinolone antibiotic is very old now, not usually used anymore. There are better, newer antibiotics that will treat the same thing without the side effects, because I think the side effects are like nausea, diarrhea, insomnia sometimes. Children, it does tend to cause musculoskeletal injury, so it's not great, and there are definitely better antibiotics. I think one of the very serious uncommon side effects is nerve damage, permanent nerve damage, or something like that. So not a fun time, and really shouldn't be used if there are no other alternatives, because there are definitely better quinolones and newer quinolones that'll do the same job. And even then, there are other antibiotics that'll do the same job anyway. So just fun fact for you, that this is an actual chemical structure. I had to look it up. I was pretty sure it was a quinolone. I just wasn't sure which one, because, you know, they all kind of look the same when you study all of these for 4 years or whatever. Looks like he can just get them out of thin air. Nice, 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 nice. I wish I could do that. That would be great. I'll have to look up the actual words about that. By a reincarnated pharmacologist and a parallel world. So pharmacology, the study of how drugs work in the body, essentially, I would say is a part of pharmacy. So it is kind of interesting that they don't just say a reincarnated pharmacist. I guess in the intro, he did say that it's been a while since he interacted with patients, sorry. So maybe that is a more accurate representation of what he's doing nowadays. So, yeah, sure.
も ファルマ様？はい、ファルマ様はファルマ様。
I do enjoy that his name, because Pharma, like pharmacy. And then what was it?
ファルマ様はファルマドメディシス様で。
Pharma de Medicis, so like medicine, pharmacist. You could get away with saying pharmacist somewhere in there. That's pretty funny.
ファルマ様。
I guess he also gets the joke.
製薬会社みたいなの。
Indeed.
これは
Although yours, Japanese pharmaceutical companies are like
待て、
Takeda
ってことは俺
or
死
like
んだのか。
Daiichi Sankyo, right? They're not.
多分
Yeah, some of it,
だろうな。
but a lot of them don't have pharma
も
in
し
the
か
name
して
anymore.
記憶が混乱してます？そうみたい。では改めまして自己紹介いたしますね。
Wow, that's really convenient.
シャルロットです。いつものようにロッテとお呼びください。ロッテ。はい。この包帯取ってもいいかな。なんかヒリヒリして。すぐに準備いたします。このメモ、最後に書いたやつか。あ。
Wah, wah, doesn't know when to look at his cultures. Rookie mistake, rubbing off notes that you write on your own, man.
それ。すごい薬師様の正門みたいです。いや、これはリヒテンベルク図形といって落雷が皮膚を張った時のやけど。
Correct. He's right. That is a mark that some people get when they are struck by lightning. It hits where the lightning hits. So yeah, that's pretty funny.
何拝んでるの？これは薬師様が雷からファルマ様を。そんな、あんなにお得意でしたのに、真実を扱えることが貴族階級の証。
Okay, so maybe not being a pharmacist. Being a pharmacist isn't enough, apparently. Alright.
忘れたかも。もしこのまま使えなかったらどうなる？それは考えたくもありませんが、もしそうなったら貴族としては認められず、このお屋敷を追い出される可能性が。
Oh, that'd be bad. Yeah, you better remember, buddy. You don't want to leave this house.
水の真術って言われてもな。まず心に水の姿を思い浮かべるんだそうです。水の姿。
Yeah, of course you would go there. Yeah, think about H2O, buddy. The O in the middle and then the H is coming off it.
水分子は H2O。
Hey, he's even got the ionic bonds, man. Look at him.
単結合。いや、電子状態も考えると。
A true pharmacologist. There, look at him. So then theoretically, he can just think about the antibiotic structure that we saw in the opening, and he should be able to create it, right? What a dude.
止まった。ファルマ様。ロッテ。このお水思い出せたんですね。ごめん、濡れた。濡れました。
Hey.
ファルマ様のお水涼しくていい気持ちです。それにお庭のハーブの水やり助かりました。着替えてそちらへ向かいます。
Where's the other servants? This is a huge household. They can't just be her.
本当に出たよ。水以外も出るのか？
Hey. Okay, hold on. Is this just elemental? So he can make elements, right? And then he can put them together. So essentially, he can just, if he remembers all his chemical structures, he can literally just make everything. I wish I could do that. That would make my job a lot easier. Oh, my previous job a lot easier. Anyway, when I was giving out medications and stuff like that, I could just think about it. Oh, give me aripiprazole. Oh.
混合物は不可能。左手で物質創造、右手で物質消去できるのかな。構造を知ってるものならだけど。
Yeah, man, you better get to studying.
あ、
I mean, he's made gold and salt and stuff and sugar.
無事思い出されたのですね。やりました。よかったです。これできっと旦那様も一安心なさいま。もしかしてファルマ様、今までの薬学知識もすっかり忘れてしまいました。え？お気をつけください。旦那様はお食事の際によく抜き打ち
I want to see this quiz. Hold up. We'll skip a little bit forward till we hit the quiz.
すごい家族だったんだな。これから俺はファルマ少年と一緒に生きていこう。
Is this it?
ところでファルマ、お前の両手の治療に使った軟膏、ゲオライドの調合法は
Okay, no idea. Because that is nowhere near modern medicine.
ゲオライドはハーブとカテッソの油、トカゲ
Does
の
that even exist? Hang on, let me Google that. I don't think it exists, but I'm just gonna make sure. I just realized putting georide in probably isn't a great idea. Nah, it doesn't exist. Alright, good. Yeah.
コウモリの翼の粉末とともに
Definitely
満月
doesn't
の夜
exist. Alright,
身
cool,
を
cool,
清め
cool, cool,
祈り
cool.
を捧げてから清水で一晩煮詰め3日間天日で干し乾燥させた後細かくすりつぶしたものです。
結構認知機能にも影響はなさそうだ。大事なければ明日よりエレオノールの授業を再開させてもよいな。
はい、わかりました。
おかしい。
何がですか？
絶対におかしい。落ち着いてるし雰囲気違うし可愛げないし別人みたいだわ。
そうですか。気のせいだと思いますよ。
ほらそれ話し方。
わかった。普通に話すよエレオノール先生。
でしょ。あなたのお父様の一番弟子にしてあなたの
It's
家
really
庭
weird
教師
how
エレ
all
オ
these
ノール・ボル
ladies
フ
tend
は
to be like.
相性はエレン。
I mean, I get why. It's an isekai, right? So they all have to be, you know,
ね
fairly good
ごめん
looking.
雷に打たれてから記憶が曖昧なんだ。
まあそれを早く言ってよね。真実の方は覚えてるわよね。
一応。
いいわ。今日は薬学の講義でなく真実の基礎からおさらいしましょう。
Based on the father's question, I don't think the pharmacology would be very accurate
私た
anyway.
ち貴族は全員真実の適性があってそれぞれに守護神を持ってるの。あなたとお兄さんとお師匠様は薬神が守護神、私は水神が守護神よ。真実には火、水、風、土、無の5属性があり、さらに生属性と不属性に分けられる。
I got nothing on this, so I'm gonna skip forward. I don't think I can really add much
人
to
か水はなんと
frickin'
なくわ
magic.
かるんだけど、無の属。ねえエレン、メガネがないときはこうするといいよ。ほらこう。
What is he trying to do?
何それ。
いいか
Trying to cheer
ら
her up?
騙されたと思ってやってみてよ。指の穴を細く狭めるんだ。もっと針の穴みたいに。
すごい。
Gives us somewhere to focus on? Way!
あれ？
どうしたの？
いやちょっと。ごめん、そんなに強く触ったつもりは。
今朝ついちゃって痛いな。なんでわかったの？包帯もしていないのに。
いや、なんでっていうか。
He can see shit?
月指。
Whoa! He can see injuries!
色
What
が
a
変
dude!
わった。いや、こうやると
Now,
体の悪い
does
とこ
that
ろ
extend
が
to
青く
like
光るみたい。
internal
で、
injuries?
原因を
Or
当てる
like
と白く光る。
diseases which aren't necessarily injuries per se?
薬神があらゆる
That'd be very useful.
薬を授ける。そんな、それってまるで薬神の心眼じゃない。
He has the Sharingan.
なんなの
Sharingan!
なんなのよ
He has the Sharingan!
そんな能力人間じゃないエレン待って春馬くんなんでないのあなたの影
He's not real? What? How did she get her glasses? The whole point was that she didn't have glasses. Oh, maybe it was out of her pocket or something. No.
大丈夫ちょっと待ってエレン
Where the hell is she going? I don't know what to think about this. It clearly seems to be going for... It's still Isekai, right? There are some more technical details in here than necessarily the other one. The Drugstore in Another World had. Where it actually, tries to talk about chemical structure and the rest of it. But obviously still most of it is kind of fudged, right? I think the parts that were in the real world about the university studying, that kind of thing, is for the most part pretty correct. People who do that more than I do for a living can correct me, but I think that was pretty correct. Most of the all the chemical structures they showed pretty much are correct. So yeah, seems fairly interesting. The Isekai bits seem to be headed somewhere, which is nice. I think Drugstore in Another World was too slice of life for a lot of people, but here it seems to have a little bit more of a plot surrounding how he got transported, right? And what these different powers mean for him. So I think in terms of a show, this will be better in that it might be more interesting. Drugstore in Another World was just kind of going through the motions, right, of a slice of life anime. So I think this particular one might offer a little bit more action with, some more sprinkled medical knowledge in there. I do find it really interesting that this is like the second Isekai Pharmacy show this year. All of a sudden, I don't get why. I don't get why there's a sudden fascination with it. Maybe it's because of, the global situation in general. And the people that researched the vaccines and things like that. It's just hats off to you. I mean, I know that they were looking at it, for a long, long time afterwards, or beforehand, sorry, for other illnesses and things like that. But to have such a quick turnaround, which I know for us regular Joes felt like a long, long time. But trust me, in the medical world, having that fast turnaround where we have effective medications within a year or two that's proven to be safe and efficacious is incredible. And exceptional circumstances call for exceptional reasoning, right? So yeah, if you are interested in my thoughts on the other Isekai show that I've been referencing throughout this one, Drugstore in Another World, I do have all 13 of those episodes already looked at in a playlist for you. I'll leave a link probably top left to the first episode and a link in the description. If you're more interested in kind of Japan in general, I also have some foreigners guides on Comiket and how to buy some stuff from Japan while you still can't go. And I've got other videos that are in the cooker as well. One particular video, the script is like, it's getting nearly 30 pages long, and I really need to start filming for it at some point. But, we'll get to it. In the meantime, you can expect more videos like this every week as these episodes come out. Hopefully they have more technical detail that I can espouse more on, provide a little bit more insight on. If you have any questions about what I've talked about in this episode, feel free to leave them down below. If you need to correct me, by all means, also leave that down below so then we can all learn together. But otherwise, I think the show has potential as an actual show. It seems to have more of a plot thread, and I can't wait to see where it goes. So, Until next time, I'll catch you guys later.